I'm Ryan Dillon. This is my Capstone 1 presentation. The project is an automated plant monitor system. It's a system that monitors the pH and water level of hydroponic plants and maintain and research them in order to grow better produce. It's a table of contents. So the first question is, what is wrong with growing plants in soil? Plants grown in soil generally need vast amounts of water and vast amounts of energy to pump water out across the fields to them. Agriculture accounts for 70% of all global freshwater withdrawals, according to the Food and Agriculture Organization of the United Nations. And in a state like Arizona, where water conservation is vital, this is a huge problem. Hydroponics can reduce water consumption of a plant by 10 times. Plants grown hydroponically often grow faster, bigger, can be grown indoors, basically anywhere, are more nutritious, there are no pests and almost no diseases in hydroponics. The only real downside is that they are more expensive than soil-grown plants. So if you look at what's wrong with current automatic hydroponic agriculture systems. If you look at the AeroGarden Elite, which is one of the cheapest, most popular, most effective options on the market, it's very expensive, very small, and it can only effectively grow very small greens like lettuce or microgreens. Even lettuce starts to become overly constrained by the size of that system. Then the other larger automatic hydroponic systems can grow large plants, or many plants at a time, but are exorbitantly expensive, and they can cost upwards of $600 or more. You can see in this it says it starts at $700, right? So my goal in this project is to create a relatively inexpensive alternative to large, expensive automatic hydroponic systems. My approach is to find the most effective and cost-efficient items that will maintain the same kind of accuracy as a commercial automatic hydroponic system. A secondary goal in this project is to read and save data from an inexpensive electroconductivity ppm meter onto a computer. There are very few inexpensive compatible options available for reading the dissolved solids on a computer and recording that data, but I believe that this can be done using an Arduino and rewiring it to the readout pins of an AC meter. And this is just more examples to back up the science behind this project. This is not my data, but this is the kind of data that I would like to reproduce and use to improve my system. This study clearly shows how different types of nitrogen ratios in the grow nutrients for hydroponic plants significantly affects plant growth. My project is designed to monitor these different variables so that we can understand how different factors affect the growth of plants and to subsequently optimize their growth. So for example, here you can see you have trend lines for like a control nutrient solution and these different ratios, and you can use that to obviously make the most competitive, best tasting, most nutritious plants on the market. So here is my architecture diagram. Let's see. Probably going to stay here for a second. So I'm going to use a ppm, electrical conductivity parts per million meter, to check the strength of the nutrient solution, and it's checking the dissolved solid, so it's how much of the nutrient solution has the plant absorbed, yeah, and as I was saying, I'm going to try and rewire it to be read by an Arduino, and subsequently have a program that can constantly read the ports of an Arduino and save that as text data onto the laptop, and then also have a separate Java program reading from those text files and sending alerts based on the information. And so then also I would have a ultrasonic sensor to measure the water level in whatever the growing medium is, a tote or a box, or I chose an ultrasonic sensor because it can be very accurate at doing this, and I already had one. And both the water level and the dissolved solids are very important to measure, because those are vital to the plant's health. Too much water can drown the plant. Too little water, obviously the plant is not going to be able to get the nutrients, and you need, as time goes by, the dissolved solids will go down and down as the plant absorbs them, and so you need to monitor that. And then the grow lights they'll be an entirely separate system apart from the Arduino. They're going to be connected to, I think one of them has a built-in timer, and the other one will have an outlet timer, and those obviously just go to the outlet. And the biggest part after that is writing that Java program so that it maintains and it keeps track of the dates of when the individual plants were germinated, so you know when to switch from grow solution to bloom solution, when you can expect to harvest the plant, and then it'll send alerts on when the water level is getting too low, on when the dissolved solids are too low. And then after that, I have my preliminary bill of materials, and I wasn't exactly sure if I should add in things that I already own, so like the Arduino might be like $35 or something, but for this, it's not going to cost me anything more. I have an outline of my project plan and the software that's going to be required to complete this. And I have some customer archetypes and user stories for who this system would be useful to. So let's see, like for example, you could just read through them here. If somebody's living in their apartment, it could be useful to them if they have a tight budget, they can't afford other systems. My project was the actual implementation was set back because I switched projects midway through, and I'm working by myself, but I am motivated to create the prototype for this system, and I intend to continue working over the summer. So that's it.